Okay, today I want to go over section 1.5, which is still a review of algebra and trig. This time we're going to do inverse functions and logs. And in this section we're also going to review a lot of not a lot of trig, but some of the trig that we went over in Math 1560, namely the unit circle, inverse sine, inverse cosine, and all the inverse trig functions. So let's recall first the definition of a one-to-one function. We say that a function is one-to-one. A function f is one-to-one. And the notation I'm going to use is 1-1 for that. On its domain, D, if now in algebra we used to say that a function is one-to-one if for each x there's exactly one y, and for each y there's exactly one x. We would do it in writing. Here we're gonna do it using algebraic terms. So a function is one-to-one. It means, like for something like this is not one-to-one, because if the y values are equal, then the x values are not equal. Like x1 could be different from x2, but yet f of x1 equals f of x2. Okay, they're the same value. To be one-to-one, if f of x1, if the y values are equal, then the x values must equal. That's what makes it one-to-one. And again, in algebra we used to say if you have 2, 3, and this was a 3, to be one-to-one, then this must be a 2. If the y values are equal, then the x values are equal. So this is what we're going to write down today. So it's one-to-one if the y values are equal, f of x1 equals f of x2, then for sure the x values will equal. Otherwise it won't be one-to-one. For every x1, x2 in the domain, every x1, x2 in the domain D. And you know the horizontal line test. We have a vertical line test for function. No vertical line can cross the graph of a function more than once. We also learned for one-to-one, no horizontal line can cross the graph of a one-to-one function more than once. So for something like this, this is not even a function, so it's not even one-to-one. And for something like this, it passes vertical line test and horizontal line test, so it's a one-to-one function. Okay, this is just all review. If you look at number 12, page 64, number 12, page 64, it says a function is given, determine whether it is one-to-one. So we're given the equation. Of course we can graph it and use the horizontal line test and vertical line test, or we could just use algebra. So we say for G to be one-to-one, for every x1, x2 in the domain of G, where G of x1 equals G of x2, we need to show that x1 equals x2. So G of x1 is cube root of x1, G of x2 is cube root of x2, and if we cube both sides to get rid of the cube root, we get x1 equals x2. So that means G is one-to-one. Okay, so if the y values are equal, then the x values are equal for any x and y values we pick. That's what makes it one-to-one. Now the inverse, let's define the inverse function as we did in algebra and trig. So let f be a one-to-one function. Let f be a one-to-one function with domain A and range B. So domain of f is A, range of f is B. then its inverse, remember inverse meaning swapping x and y, its inverse function, and we're going to use the same notation that we used in algebra, has domain B. Remember, B is the range of f and range A, because we're swapping x and y. A is the domain of f such that f inverse of y equals x if and only if f of x equals y. So basically what this means, it means if xy is a point on the graph of f, belongs to the graph of f, then yx belongs to the graph of f inverse. That's what this is about. Okay, if f inverse, if and only if, it works both ways. So for example, just to go back to algebra so we can make this clear, if the function f has ordered pairs 1, 2, 3, 7, and 9, 15, then its inverse would be 2, 1, flipping x and y, 7, 3, and 15, 9. So basically what we're saying, if xy belongs to the graph of f, then yx belongs to the graph of inverse. That's what this is all about. And this is like saying, if you look at this again, this is like saying f inverse of y, but y is what? Y is f of x. F inverse of f of x equals x. And again, this is f of f inverse of y equals y, because x is f inverse of y. Okay, so basically that's what this means. So to be inverses of each other, when you do the composite, either way, it takes you back to x. Nothing changes, which is obvious from here. Look, f of 1 is 2, f inverse of 2 is 1. So basically f inverse of f of 1 is 1 itself, because f of 1 is 2, and f inverse of 2 is 1. So that's what this is about. Let's look at 16, page 64. Page 64. I'm not sure this is 16. I think I got the wrong number here. X to the 5 plus x cubed. All right, never mind. This is just a problem. So we're given, I'll just say an example, okay? So this is an example. It's not 16. So if we say given f of x equals x to the 5th plus x cubed plus x, find part A, f inverse of 3. Well, to find f inverse of 3, we have two ways. Either we find the equation of f inverse and plug 3 in, which is not easy in this case, or we find f of a number equal 3, and then f inverse of 3 is going to equal that number. And you can see from that, if you put a 1 in there, 1 plus 1 plus 1 is going to give you 3. So since f of 1 is 3, then f inverse of 3 is 1. So that's easy because it's a 1 that's going to make it work. And part B, what is f of f inverse of 2. Well, since these are inverses of each other, f of f inverse of 2 is just 2. Remember, we just talked about the definition of the inverse just right now. Okay? I need to white this out. So let me fix this. Okay. So next we're going to go to so given the equation of a function, if it's possible, how do we find the equation of the inverse? So to find the equation of the inverse of a one-to-one function f, we're going to go through steps. We're going to first write y equals f of x. So write the equation in terms of y. Switch x and y because that's exactly what inverse means. Isolate y if possible. If it's not possible, then you can't find the inverse. And then the y that you isolated is going to be the inverse. Okay, 4 steps. So for example, how do we find that f of x equals 4x minus 1 over 2x plus 3? Find the equation of f inverse. So the first step is to write y instead of f of x. So y equals 4x minus 1 over 2x plus 3. Switch x and y, so instead of y, it's going to be x equals 4y minus 1 over 2y plus 3. Now we're going to isolate y. So we're going to get rid of the fraction by timesing y 2y plus 3, both sides of the equation. So we distribute the x, we get 2xy plus 3x equals 4y minus 1. Remember, we are trying to isolate y in this case, okay? We're trying to isolate y. So this has a y term, and this has a y term. So we want the y terms on one side, the constants on the other side. So we add 1. And then subtract 2xy. So we get 3x plus 1 equals 4y minus 2xy. To isolate y, we gotta factor it out and divide by 4 minus 2x, and that is going to be the inverse. Okay. And graphically speaking, the graph of a function and the graph of its inverse are symmetrical about the line y equals x. And I'm going to show you an example about that. The graph of any function f and the graph of f inverse are symmetrical about the line. And the reason it's y equals x, because remember, to get the inverse, we swap x and y. So for example, number 36, page 65. Number 36, page 65. Let g of x equals cube root of 1 minus x cubed, where x, okay, find g inverse. How is it related to g? And then graph. Okay, so g inverse of x. Well, let's go through the steps. First, write y equals cube root of 1 minus x cubed. Switch x and y. So x equals cube root of 1 minus y cubed. Now to isolate y, we gotta cube both sides to get rid of the cube root. So we get x cubed is 1 minus y cubed. Move the y cube over and the x cube over. So y cubed equals 1 minus x cubed. And you can see that the inverse of 1 minus x cubed is exactly the same function. So how are they related? It's the same function. And you can see that if you do the graph, that's what they want you to do in part B. Okay, if you graph, let me delete what I have in there. If you graph y equals cube root, so math for cube root of 1 minus x cube, and then cube root, and then another one, cube root of 1 minus x cube, and the line y equals x, which is a line of symmetry. So you can see this is the graph of 1 minus x cube. If you draw this, it's drawing over it because it's a reflection of itself. You see the line y equals x, how it's going to now split it up evenly. So if you take the top piece and do a reflection, it's going to be that. If you take a bottom piece and do a reflection, it's going to be that. That's why it's the same graph. Normally it's not, but this time it is. Okay. Now I'm going to pause a little bit and then I'll be right back.